Okay, Mayur, we'll start the class. So, did you attend last class? Hello.
One second.
Yeah.
On index properties, I believe, yes.
Last class, I was discussing about some consolidation
Oh,
also.
effective stress, yes, yes, effective stress, yes.
Yeah, so if you are there, then I'll just continue the same thing. I will solve two problems today. So, let me check. Can you see the slide now?
Yes, sir.
Yeah. So, this till here we discussed, if you remember. So, let me. So, last time we have discussed about effective stress. Uh, Effective stress as well as consolidation settlement formula we have derived, right? Now we'll go through this problem once using the properties of the clay layer derived from the above question. So what are those properties which we have derived? One is void ratio, which is equal to zero point 0.6. Another one is saturated unit weight, that is equal to 20.625 kilonewton per meter meter cube. Okay, so this does not have units E. Now we have found out these two in the last question, and we have to use these things in this question. Now the consolidation settlement of the same clay means which has same properties, uh, under a square footing. Under a square footing, this is square footing, you can see only one cross section, one side cross section, neglecting its self weight. So there is some external load, you can take it as q equal to 200 kilonewton, um, with additional data as shown in the figure. So what you have to find out is consolidation settlement of the clay layer. See, sand will not consolidate over the time. It will consolidate within very small time. You can say within some number of hours. Okay. Whereas when we are talking about consolidation settlement, it is purely related to clay only. See, here we have clay, only this much. From here to here it is clay. So it will consolidate. The above sand will not be consolidating. That is already in consolidated state always. Now assume the stress distribution as one horizontal to two vertical from the edge of the footing. From the edge of the footing, you can see in the diagram already given. So gamma W should be taken as 10 kilonewton per meter cube. Now, if you remember, you see this. This is the equation which we have derived. This is the consolidation, primary consolidation settlement, whose formula is H naught. Its initial clay layer thickness or initial bed thickness divided by 1 plus E naught. Initial void ratio. This H naught E naught naught will denote as initial conditions. Okay. H naught by 1 plus E naught into Cc. This is compression index, coefficient of compression index, then log of current stress divided by initial stress. um, I'm just confirming, are you following now,
Yes, sir.
Mayur? Yeah, okay,
Same
fine.
things.
Yeah, fine. Okay, now this is the current stress and this is the initial stress. This is initial, this is current stress. How do you calculate current stress? Initial stress plus the extra stress will be the current stress. Initial means previous stress divided by this previous stress. Okay, that is how the formula is. Okay, let us write again. First, I'll write given data on left side, so I'll divide into two parts. Okay, so given data is initial void ratio that we have calculated. We have been given gamma sat of clay Given means we have only calculated 20.625. So you have to remember this. If at all you have done wrong calculations in the previous question, then you will use those wrong e value and wrong gamma sat value in the next question. That means you will be losing 4 marks if you are doing something wrong in the first question. So that is the reason why you should be very much careful while doing these problems. Now these are, anyway, we have another load is given as 200 kilonewton. Okay, then gamma w as 10 kilonewton per meter cube, cc as zero point 0.4, cc as zero point 0.4. Anything else? Yeah, this is sand unit weight. We have been given sand unit weight in this problem specially. For this clay, we know this is 20.625 and E value is 0.6. I'm writing. Now everything is given in this figure. See, now let us write the formula first to find out the settlement. S equal to Cc into H naught divided by 1 plus E naught multiplied by log of initial stress plus the extra stress, effective stresses. Okay, you have to take initial stress. So now just substitute Cc as zero point 0.4, H naught. H naught is initial height of the clay. What is this? Here only you have to take this clay height. Clay height is 1 meter, right? Okay, 1 meter divided by 1 plus zero point 0.6 log initial stresses plus that we have to calculate. We will calculate now. Okay, now uh, 200 is the external load. Before this load is applied, there was some initial stress at one point. Okay, due to that it is already see, because of the initial stresses, consolidation might have happened already. Now the question is about, due to this extra load, what is the settlement? That means you have to take this as delta sigma v. Already existing remaining are all existing stresses. So where should you find out whatever stresses due to these are existing stresses? The point you have to consider is the middle point of this clay layer. So you can calculate the settlement at this point, at this point, at this point, anywhere in the clay. But to get the average value, you have to go for the middle point. So our aim is, I'll just rub it. Our aim is to find out settlement at midpoint of this clay layer. Okay, now what shall we do? This distribution of the stresses due to this, it will be in this direction. See, it is given 2 vertical, 1 horizontal, right? Like this. So at this point, at the middle point, see, this is the area over which this load is distributed, right? That is one thing we should remember. Next, initial stresses, there is nothing to do with this 200 kilonewton. Initial stresses will come due to unit weight of the soil. Okay, now let us find out the initial stresses at this point. Okay, at this point. So how to calculate effective stress? Effective stress due to unit weights. We have studied this. Sigma effective equal to gamma bulk multiplied by height. Height of or depth at which that point or at which you are calculating this effective stress. If it is bulk, that is fine. If it is saturated clay, if it is having water table, then you have to go for gamma submerged multiplied by r multiplied by h. Gamma submerged, how do you get? Gamma sat minus gamma w will be gamma dash. Okay, why we are doing this effective stress? I have already told you in the last class that Effective stress is nothing but total stress minus pore water pressure. What is total stress in case of water table? You will calculate gamma sat minus, sorry, gamma sat into H minus pore pressure is nothing but water pressure. Water pressure is gamma W into H. So H is anyway common. Gamma sat minus gamma W into H. If you directly deduct unit weight of the water from the unit weight of the saturated clay or saturated soil, you will directly get this is called as gamma submerged. If you multiply gamma submerged by height, you will get effective stress. So directly, instead of doing this, total stresses, pore water pressure, again, instead of doing this, directly we will multiply gamma dash with H. So that is what we will do here now. Okay. Uh, at this point we have to calculate sigma dash, right? Due to this clay weight, there are some stresses, initial stresses. Now see, there is this much sand is there, but there is groundwater table above the sand. That means you have to take submerged unit weight of the soil. That means gamma sat minus gamma w multiplied by this much height. Okay, that is height of the sand, plus this, right? What is this? Here this is also saturated because water table is above completely, it is covering everything. So gamma saturated already we have calculated. So this is about sand. Okay, this is of sand plus gamma saturated of clay minus gamma w into height of the clay above this point. Okay, so now we'll do those calculations. Let us say that midpoint is P. Okay, now sigma dash P is gamma saturated of sand minus gamma water multiplied by total height of the sand, because total height is there above that point. Height of the sand plus gamma saturated of clay minus gamma W multiplied by height of the clay. So can you tell me in this? See, gamma W is given 10, so 18. So 18 minus 10 is 8 multiplied by H. H is 2. Okay, 18 minus 10 is 8 multiplied by H is 2 plus gamma sat 20.625 minus 10. That means 10.625 multiplied by H is how much? There is, this is 1 meter. Total is 1 meter. If you take about the midpoint, that is 0.5 meter. Okay, you do this 0.5. Can you tell me what is this sigma dash P? Can you calculate and tell me?
21.3125.
Can you come again? I can't hear.
21.3125.
Okay. What are the units? Can you tell me the units also?
It's stress, so kilonewton per meter square.
Correct. Okay. So now we will calculate the extra stress which is coming due to this 200 kilonewton. Okay. So it is distributed over wider area. Okay. So there is a sand below whose height is 2 meters. Okay. Okay. Just a minute. Acha, acha. It is located here. So my mistake. Ah, shit. So it is located at the mid depth of sand. Okay, this is sand, this is 1 meter, this is also 1 meter, and this is clay whose total height is 1 meter, but we need to find out at the mid depth by taking that. So over this area it is, this load is distributed. Why I am doing this? Because I need to find out the increment in the stress at this point. That increment in the stress, that means point load divided by area over which it is acted. We are given point load, but we should find out the area over which it is acting. Okay, so if this is 2 meters and if it is two vertical, one horizontal, can you tell me what is the length of this? Can you see the slide? Hello, uh, can can you tell? Okay, I'll explain then. See, when you go down by 2 meters or 2 units, you have to go 1 unit horizontally. Now, how much you are going down now? From here to here, 2 meters, sorry, 1.5 meter. 1 meter plus zero point 0.5. This is zero point 0.5. So when you are going 1.5 down, how much you have to go this side? See, when you are going 2 down, you have to go 1 horizontal. See, if you are going by 1.5, it should be 0.75. In the same way, this should be 0.75, right? So what is this already? This is 2 meters. 2 meters plus 0.75 plus 1.75 will be 3.5. This distance is 3.5. So in this direction, 3.5 perpendicular to the board also another, it is 2 meters, again in this direction also 3.5. So totally this load will be distributed over an area which is equal to 3.5 meter by 3.5 meter. Okay, so that is the area on which this 200 is distributed at this point. Now we can we calculate what is delta sigma. Now P is 200 kilonewton divided by the area over which it is acting is 3.5 square. Can you tell me on quickly what is this? I'm expecting this. Mayur, can you hear me? Can you confirm?
The second.
Actually, I can't hear your voice. I don't know why. Yeah. Can you tell me again? You can write, or else you can write. You can write in the chat box. Correct. 16.326. Okay. 16.326 kilonewton per meter square. This is the delta sigma. You have sigma with you. What is that value? Sigma is 21.3125. So you can substitute all these values, right? 21.3125 plus 16.326. Now you have to tell me what is the final value by calculating. Just tell me what is S now. So take 1 minute, please solve and tell me. So you can write the answer here in the chat box. I am also calculating here. I am not taking that much time. Why are you taking? Everything is ready. Point 6174. Can you tell me further digits? Because answer should be in the mm. So you have to get as many decimals as possible. Okay. So yeah, for the timing, I can say some. I can write that point zero six. What is that? 6174. 6174 meters. So if you convert it into mm, 61.74 mm. Okay. So this should be the answer. Let us go back to the question and just check. 61.75 mm. So that answer must be where is that? Answer must be 746 something like that, or more than 5 or 5, so that it will become 61.75 mm. Okay. So answer should be B. Okay. Is there any doubt in this problem?
No, sir, got it.
Got it. So let us move to another question. Okay. So this question is also from 2009 question paper gate. So question number 35 having 2 marks for it. So if you go through the question, then I can tell you what is this about. The laboratory test results of soil sample are given below. Percentage finer than 4.75 mm equal to 60. Okay, it is already in the percentage. Percentage finer than 0.075 mm is 30. Liquid limit is 35%. Plastic limit is 27%. The soil classification is GM, SM, GC, ML, MI. So here we are talking about soil classification, right? So Mayur, uh, which year you are in? Which year, BTech or MTech?
So third year.
Third year BTech. So have you studied about soil classification before?
Yes, sir, I did it.
Acha. So do you know about? I mean, have you heard about Indian soil classification system?
Yes, sir.
Yeah. Okay. So let me go through that roughly, some introduction, so that we can solve this. Indian soil classification system. Okay, so whenever we are given any soil, first there will be, we will try to find out whether it is coarse grained or fine grained soil. So fine grained, coarse grained means what? These are depending upon the grain size. If it is more, we generally say it as coarse. If it is small size particles, we'll say it as fine grained soil. So, so here, whenever we are given soil, what do we do? We will take 75 micron sieve. 75 micron sieve means 0.075 mm, right? So taking that sieve, we use in our homes. Taking that, if you pour all the soil here, if you keeping all the soil here, if you sieve it, if you if this can sieve more than 50%, okay, the passing thing is, this is which sieve? 75 micron sieve. If 75 micron is sieving more than 50% of the soil, that means you can say that greater than 50% of the soil is finer than this 75 micron. If that is the condition, this is called as fine grained soil. If less than 50% of the soil is passing, okay, less than is passing through the through sieve, 75 micron sieve. Okay, if less than, that means the retained is more than 50% in that case. So that means it is coarse. First, we should divide the soil, we should grade the soil depending upon this. Once we grade that, again we can go deeper and we can again classify the soil according to the deeper parameters. But right now, to know that, we need to do this thing. What? First, use the 75 micron sieve. It is fine grained soil if greater than 50% is passing through passing through 75 micron sieve. So otherwise it is coarse grained, right? Otherwise it is coarse grained. It is nothing but greater than 50%, 75 micron. It is sorry, greater than, if less than, sorry, less than 50% is passing through 75. After, once you get this, suppose it is you have got coarse grained soil, that means less than 50% is passing, more than 50% is retained. Then what do you do? Taking that total soil again, total soil, what do? You use 4.75 mm sieve. Okay, 4.75 mm sieve. Taking that 4.75 mm sieve, you will sieve that whole soil. From that, if more than 50% is passing through this, so more than 50%, sorry, I'm rough. In the next class I can give you a detailed classification, but for the timing I'm giving this rough introduction. So if more than 50% is passing through 4.75 mm sieve, okay, that means again it is finer. In the coarse grained soil, it is coming under finer. That means you can give it as name of the soil is soil, sand. If less than 50% is passing through 4.75 mm sieve, then it is called as gravel. Okay, gravel, sand. Now these two come under coarse grain soil. Now again, uh, if you see here also, there will be three kinds of fine grain soil: clay, silt, organic. Organic soil. So I will discuss clearly in the next class, okay, about these things. So let us go back to the question first. So what are the things which are given here? The laboratory test results of soil sample are given below. Percentage finer than 4.75. See here, what do I do? I'll just keep 4.75 4.75 mm sieve it is. Then I'll keep somewhere here 0.075 mm sieve. Okay, these two are the sieves. What is it told? Percentage finer than 4.5. That means whichever is passing, he is telling about this. He took soil, let us x amount of soil. Out of that x amount of soil, more than 4. Sorry, percentage finer than 4.75. That means whichever is passing, that is 60% of this x. Remaining 40% is here. Okay, it is written. Okay, that is one thing. Another thing is percentage finer than, uh, again, out of those x amount, if you take again x amount, if you sieve from this 75 mm micron, what is happening? The percentage finer is 30%, and it is retained. How much is retained? 70, right? Same x amount of soil. Okay, now in that 70%, okay, or total, in the total amount, 60% is in between this. That is what this meaning. 4.75 and 0.075. Below 60%, in that 60% of the soil, some soil is going again below. Okay, that is 30% of the total amount. That is what. Anyway, now coming back to our classification. How do we classify first? First, we will do with 0.075 mm or 75 micron sieve. After doing with this, we will understand whether these coarse or fine first. So if more, greater than 50% is passing, then it is finer soil or clay, silt or organic, right? So now let us see how much percentage is passing. 30% is passing. That means less than 50%. It is less than 50% is passing. So more than 50% is retained. That means it is, first of all, the given soil is coarse grained soil. Okay, first of all, given soil is coarse grained soil. It is not finer. First, under coarse grained, there will be two things. What are those? One is gravel, another one is sand. Right? Now we should divide. We should know whether it is sand or not. For that, what do? We will take 4.75 mm sieve. Then we will sieve total x amount total. Then, if greater than 50% is passing through this, that is sand. Okay, that is what we discussed. If greater than 50% is passing through this 4.75, this is sand. So now, what is percentage finer than 4.75? That is 60. That means more than 50% is already passing through this 4.75. That means it comes under sand, not gravel. Now here I should introduce few terms. Gravel is denoted by G, sand is denoted by S, and clay is denoted by C, silt is denoted by M. Okay, it's not S. And organic matter denoted by O. Is there anything else? No. So now correspondingly, there will be, again, there will be subgrades like poorly graded, well graded, clay, gravel, sand, silty gravel, like that. So for that, I will give you the, uh, suppose in, there is some percentage of silt present in the gravel, some percentage of the clay is present in the gravel. That means what? So it's clayey gravel. See, if somebody is saying clay gravel, that means less percentage of clay is there, more percentage of gravel is there in that soil. When your this prefix is always lesser amount. As it is in front, you don't get confused that this is clay soil. It is clay gravel. It is basically gravel. It has some particles, clay particles. That's why it is called as clay particles. So now, if it is clay gravel, then people say it as GC. If it is silty gravel, it is taken as GM. Okay. Now, in the same way, clayey sand is SC, silty sand is SM. So you can divide in this way. Another thing is well graded, poorly graded. Well graded soil, poorly graded. So well graded, poorly graded definitions I will give you in the upcoming classes. Like suppose taking a soil. If soil contains different sizes of the particles, it should contain different sizes of the particles. Okay. Then what happens? So all the voids get filled by the small particles which are formed due to the big particles. When it is so, then it can form a dense sand or dense soil. So that is the reason why the well graded soil will always have different sized particles. Poorly graded means all are uniform size. When all are uniform, the voids cannot be filled by those particles again, because we need small size particles to fill these voids, right? These voids cannot be filled by this again same size particle. So if void is not filled by the same size particle, then the voids will be there and it will be loose sand. You can lose clay or lose soil. That is the reason why it is poorly graded. Uniform size means poorly graded. Different sizes means well graded. Now, depending upon that, if it is well graded gravel, you can say that well graded is GW, poorly graded is GP. In the same way, well graded sand is SW, poorly graded sand is SP. Okay. Now, well graded, poorly graded, clayey gravel, silty gravel, clay sand, silty sand, all these things will come only in case of coarse grained soils. Only in case of coarse grained soils. What about this fine grained soils? How do we classify this? We classify these using Atterberg limits. Atterberg limits are nothing but some water content in it. So there are some different water contents, liquid limit, plastic limit. These things I will introduce in the next class so that we can have the whole idea about it. So depending upon this liquid limit, plastic limit, water contents, we can find out whether it is low compressible or high compressible. If it is low compressible, we can say low compressible clay, highly compressible clay, medium compressible clay. Like that, low compressible silt, medium compressible silt, like that we can divide. Now coming back to the question again, so we found that it is sand. See, greater than 50% is passing through this. That means finally we understood that it is sand. That means S. Just see the options in which it is S is there. A, it is not there. In B, it is there. Okay. In C, it is not there. In D, also it is not there. That means the answer is B. We understood the answer is B. But what are these GM, SM, GC, and so those things I will discuss in the next class. That needs another part of the uh, study. So now this M is what I told you: silty sand, silty gravel, clayey gravel. This is again low compressible silt, intermediate compressible silt. Anyway, now the sand is existing only in the option B. Now you can say option B is correct depending upon the percentages of uh, soil particles. Now we did not use these two in the given data. There is nothing to use. There is no need to use when you are So smart, you will directly find it is sand and you will stop after finding whether it is sand or not. Then you will check whether S is there or not. If S is there in the 2, suppose there is SW here, then you will try to again subdivide by using these things. Then you will find whether it is B is answer or not. If nowhere is S, if only one option is containing, no need to use this and no need to go in deeper. You just stop with this and within 1 minute you can find out, you can get 2 marks. Not even 1 minute, half minute. So that is how you should solve. So is there any doubt for this in this?
No, sir.
Yeah, so I hope it is clear. So we'll go deeper in this topic in the upcoming classes. So for with this, we are closing this session. Okay,
Okay, sir.
bye bye.
Thank you.
Okay then.